Contactors and relays are used to switch larger loads than we can typically control for pilot devices such as push buttons and selector switches or our PLC outputs. Today we're going to talk about contactors, how to assemble them into reverse and motor starters, and two very important items that are often left out, our manual motor starters and our overload protection. On your contactor, similarly to a relay, you got two basic components. You have your coil and you have your contacts. So your coil is what's going to make the magnetic field to move the bigger contacts. And on your typical contactor, there will be at least 3 large poles, and there may even be a few smaller auxiliary contacts. Now, before we get into contact ratings, let's just do a refresher on how the contact and coil does work on this relay. So on this relay, we see the coil of wire here, and that's going to connect to A1 and A2. And then up here, we have our contacts. And so when this energizes, we're going to see those contacts move. So I'm going to take plus 24 volts. And when I touch it, you can see that contact moving. Now let's do the same thing on our contactor. So there is a tamper-proof window on the front of this one. I'm just going to slide it up out of the way. And while I can't see the contact, you can't see the mechanical linkage of this. So I have A2 hooked up, and now when I touch A1, you can see it moving back and forth. And what happens is when we do that, it is connecting L1 to T1, L2 to T2, and L3 to T3. We look on the side of it, all UL contactors require a chart saying what horsepower they're good for at 200, 240, 480, and 600 volt. Now, this is important. Your amperage rating and your horsepower rating are two different things. This contactor is good for 25 amp, but if I look at the side of it for 240 volt, it says it's a 2 horsepower contactor. So if I was to look at a typical horsepower versus amps chart, and I say, well, I've got a 25 amp contactor and I cut it a little bit low, I would say, well, we're good for 7.5 horsepower, but it's not. This one is only good for 2 horsepower. And if we ignore that chart, then we will shorten the life of our motors. So look at that. And then let's talk a little bit about how we're going to assemble this into a motor starter. So first of all, do we need to go forward and reverse? If we want to go both forward and reverse, we have to swap 2 wires. Well, the easiest way to swap 2 wires is we're going to have a second contactor right beside of it. Now, I see a lot of panels out there when y'all are starting out, and this is exactly what you do. You put 2 contactors on a panel just like this, and you call it good. But here's the danger of doing that is if we do not have these interlock, you could energize both contactors at the same time. And since 2 wires are swapped on one of them, that's going to create a dead short. So we want to make sure that we cannot energize both of these contactors at the same time. And we want to do that both electrically and mechanically. So first, let's talk about how we're going to mechanically interlock these 2 contactors. So in the case of this one, it has this little mechanical interlock right here that needs to go in between the 2 contactors. So what we're going to do is on this contactor, I'm going to pop the right cover off of it. Comes off just like so. And then on this contactor, I'm going to pop the left one off. That way they're opposite of each other. And then you'll see 2 holes there. This is going to slide right into there like so. And then that's a lot of and thens. Next, we'll put the other one right beside of it. Now let's go and take these 2 tamper-proof covers back off just so we can see what that does. So now I'm holding them together. If I press this one in, then when I try to press this one, it's not going to let me. Pull it off of that one. That'll let this one press in. And now I can't do that one. And that's what we call mechanically interlocking the 2 contactors. I'm going to go ahead and put my tamper-proof covers back on. And then on the back of it, there's a clip that'll hold the 2 together. I'm just going to put that on. Next, you're going to have 3 jumpers. And I really like this Schneider electric reversing contactor for this reason. They're really thorough on it. Because at first, when I looked at these 2, I'm like, well, I'm not sure what these are. I know these, but these right here don't come with all of them. We're going to come back to those. Let's talk about our big ones right here. So first of all, we have our top jumper because it says L1, L2, L3, L1, L2, L3. And if we take a meter, L1 to L1 has continuity, L2 to L2 has continuity, and L3 to L3 has continuity. So when we take this jumper and we put it across the top of this is just the same as taking a loop of wire from here to here, here to here, and here to here. On the bottom, we have a jumper that looks very similar, but it's going to swap the outside two wires. On the top one, when we went L1 to L1, we got continuity. On the bottom one, which is the T side, we don't get continuity. So if I go T1 to T3, I get continuity. If I go T2 to T2, I get continuity. And if I go T1 to T3, I get continuity. And so that is going to swap two of the leads on one of these contactors. So we're going to go ahead and put that on. We're going to take it back off in a second for our overlay, but we're going to take this one step at a time. And then we have two small jumpers, and one of them has just 2 points sticking out. And that one's the one that we're going to put across the A2 leads. So it just slides right up there. And then don't tighten all your screws. We're just going to tighten our A2 screws, hold that in place. And then we have the top jumper bar. And when I first looked at this, it's like, well, I don't see this on a lot of the reversing contactor kits, but this is a really nice setup they have here. So what this is going to do is it's going to connect the A1 of your left contactor to the normally closed auxiliary of your right contactor, and it'll take your A1 of your right contactor to the normally closed of your left contact. So this little jumper right here will take care of our electrical interlock for this contactor. So we're going to put it right there, and we'll go ahead and tighten up our A1s and our normally closed contact. And that gets us to our overload protection. Now, one thing we need to understand is you have overcurrent protection and you have overload protection. And we have videos on that. But a manual motor starter is going to take care of both your overcurrent protection, which is instantaneous, and your overload protection, which is kind of just being under a strain for a very long time. An overload only does the overload protection. You still need some type of circuit breaker or fuse in line with this to protect your circuit. So to install the overload, I'm going to loosen my motor starter wires back up down here, and then we'll slide our overload up into it and tighten it back up here. Now, on the manual motor starter, usually you're going to see it come in before the contactors. The overload usually goes after them. Now, you typically wouldn't see these together, but this is going on one of our motor starter trainers that we talk about the various different devices, and we talk about how you can troubleshoot burnt motors, do mega tests, and things like that. So this is just a package for us to have all this showing in one spot. But all right, let's talk about a little important, well, it's not little, it's a major important difference between how a manual motor starter works and how an overload works. So let's look at the manual motor starter first. If I take my meter and we put one lead in the top on L1 and we put the other one on T1, then when I energize it, it lets current flow. And when it breaks, it's going to break all three legs to protect our motor. Your overload does not work like that. If we do the same test on our overload, I touch it here, and then when I go and I trip this overload, notice we still have continuity. In the case of the overload, the only thing that actually breaks are these auxiliary contacts on the top of it. So what I'm going to do is I'm going to put these in our normally closed auxiliaries, and we're going to do that test again. And this is something that a lot of people get tripped up on is, should an overload wire through a normally open contact or normally closed contact? What you have to remember is we want the position that it's in when it's not tripped, and that is normally closed. So I'm going to put my leads on here. We have current flowing, and when I press the red button, that is going to simulate an overload condition. and I press it, and it breaks those contacts. So let's talk about what we need to be doing with this normally closed contact, because, we run a training class every week, and when we get to where we're simulating issues with overloads, I'm surprised the veteran technicians that come in here and don't know where this wire actually goes. Is we need to break our coils, which notice plural, 2 coils with this contact. So we're going to end up having a circuit for our forward coil, and we're going to have one for our reverse coil, which means either we would need 2 normally closed contacts, or we need to wire this through our A2. And that's why usually your overload will wire through A2. So I'm going to take a piece of wire and I'm going to connect from our normally closed one side of the contact, and that is going to go to my A2 coil. Then I'm going to take the other side of that normally open contact, and I'm going to connect it to the minus of my power supply. So I have a wire coming from the minus of my power supply, normally closed here, coming out of the other side of that normally closed contact, going up to my A2. Now, since we have the nice electronic interlock jumper here, that means the normally closed contact on this energizes this contactor. The normally closed contact on this one energizes this contactor. So I'm going to slide our guards back off so we can see both of those move. And when I touch the normally closed over here, this contactor pulls in. When I touch the normally closed over here, that contactor pulls in. And while this contactor is energized, there's no way I can get current through there to this coil. So that takes care of my electric interlock. Now let's simulate the overload with this button, and it's going to drop that contactor out. So this is the proper way to get your overload protection working. All right, so I'm going to go ahead and get this wired to my PowerFlex 525 drive and onto my motor, because one really cool part about this training is the brakes that we can do on the back of this one. So with this one, we can simulate a weak motor winding. We can simulate shorting of the motor windings. We can short our motor windings to ground, and we can learn how to use meggers. We can learn how to check resistance on motors. And so I've created this playlist right here with that, and also some really helpful videos on understanding motor poles and RPMs. See you over there.